Okay, good morning. This is Professor David J. De Los Reyes. Okay, my topic for this session will be integral calculus. Okay, let's proceed. The given problem is the integral of dx over the quantity x squared plus 16 raised to the 3 halves, and what will be equal to, the problem is asking for the evaluation. Okay, let's proceed with the solution. The solution for this that I will be doing for this morning will be solution by using trigonometric substitution. That is, we will be using trigonometric function as a substitution to the original problem for it to make it simpler. Okay, let's proceed. We will let x equal to 4 tangent of theta. Dx will be 4 secant square of theta differential theta. If we try to take the differential of both sides, the differential of x will be dx, the differential of 4 tangent of theta will be 4, the differential of tangent is secant square of theta times its differential theta. Okay, let's try to compute for the one inside the quantity. We'll try to compute for x squared plus 16 in terms of a trigonometric function. Okay, so if x is equal to 4 tangent of theta, x squared now will be 4 tangent of theta quantity square plus 16. This will be 16 tangent square of theta plus 16. We factor out 16. So what remains inside will be tangent square of theta plus 1 close quantity. And this should be equal to 16 times secant square of theta. There is an identity that 1 plus tangent square of theta is actually equal to secant square of theta. 1 plus tangent square is actually secant square of theta. It is this. Okay. So we now know the equivalent of x squared plus 16 in terms of theta. Okay, let's try to bring out the equivalent of x squared plus 16 if we raise that to the 3 halves. That's the given problem, right? So by using this value here, okay, x squared plus 16 is actually, this can be factored out to 4 secant of theta quantity square. Because if we try to square this one, it will be 16 secant square of theta. But it can be written as 4 secant of theta quantity square. Raise that again to the 3 halves. That's the given problem. Okay, so these two here cancel with this. So the remaining power of the right hand side will be, it will still be 4 secant of theta. The remaining power is 3, so this is raised to the third power. 4 raised to the third power is actually 64. 4 times 4 times 4 is 64. And secant of theta to the third power is actually secant cube of theta. This is theta. Right? We take the value of secant, we raise that to the third power, or just simply secant cube of theta. Meaning the equivalent of this, the original problem on the denominator, is actually 64 secant cube of theta. Okay, I will rewrite the original algebraic equation, and this will now be equal to, I will now make the substitution. Okay, that's why the solution is trigonometric substitution. So this will be equal to, I will bring out the equivalent of dx in terms of a trigonometric function, that is 4 secant square of theta differential theta. And the equivalent of the denominator, and we have done it separately for us to be systematic, that is x squared plus 16 raised to the 3 halves in terms of theta is actually 64 secant cube of theta. So the denominator in terms of theta will be 64 secant cube of theta. 4 over 64, that's 116, right? And secant cube of theta can be written as secant square of theta times secant of theta. Okay, so actually this secant square of theta cancel with this. We bring out 4 over 64, that's 1 over 16. So what remains inside the integral will be differential theta. There is 1 secant of theta that remains on the denominator, that is secant of theta. But secant of theta is actually the reciprocal of cosine, that is 1 over secant is cosine of theta. So the right hand side can be written now as 1 over 16, the integral. Instead of writing differential theta over secant, we can replace it as simply cosine of theta differential theta. And this is now integrable. Okay, the integral of the cosine is plus sine, right? So this should be 1 over 16 sine of theta. Let's see. This is now our answer in terms of theta, but we must have to bring out the original variable. So to bring out the original variable, by using this representation here, we draw a right triangle, because from that, if we try to divide both sides by 4, tangent of theta will be x over 4. Tangent of theta from this is x over 4. Tangent is opposite over adjacent. This is theta. So if this is x and this is 4, the hypotenuse will be the square of x plus the square of 4, which is 16. And in here, if we try to take the sine of this, we need the sine, right? It will be the opposite over the hypotenuse. So sine of theta in terms of x will be x over the square root of x squared plus 16. So our final answer now will be 1 over 16 times the quantity. The value of sine of theta from this will be x over the square root of x squared plus 16 close quantity plus c. That's our final answer. Good morning from Los Angeles.